The minimum distance between a water pipe and the main incoming electrical service during an excavation depends on a few things. Firstly, code requirements. Secondly, the type of pipe. Thirdly, the depth of the excavation. And fourthly, soil conditions. Local building codes and regulations can vary and specify different minimum distances. Different types of pipes, like copper, plastic, or cast iron, might have different separation requirements. The deeper the excavation, the greater the minimum distance needed might be. And finally, the type of soil that is present can also affect the minimum distance. Here are some general guidelines. For copper or plastic pipes in normal soil conditions, the distance should be at least 3 feet. For cast iron pipes or when dealing with difficult soil conditions like rocky or wet soil, a minimum of 4 feet is generally recommended. When the excavation is deeper than 6 feet, a minimum distance of 5 feet is suggested for any type of pipe. The main incoming service is typically located near the property line. If the excavation is near a building, additional distance might be needed to maintain the safety of the foundation. If other utilities, like gas lines or additional electrical lines, are present, additional precautions might be necessary. Given the general guidelines, the minimum distance between the water pipe and main electrical incoming service in an excavation should be at least 3 feet. It's important to consult the local building codes or a qualified plumbing professional to get precise requirements for your specific situation. They can assess the conditions of your site and give the most accurate guidance. Maintaining proper separation helps prevent potential hazards such as electrical shorts due to water pipe damage or corrosion caused by electrical current. Always prioritize safety when working near underground utilities. Failing to adhere to the minimum separation distance between water pipes and electrical service lines can result in several potential consequences. Firstly, there is an increased risk of electrical hazards. If a water pipe is damaged during excavation and comes into contact with an electrical service line, it can create a path for electrical current to flow through the water pipe. This can electrify the water and surrounding soil, posing a severe shock hazard to anyone who comes into contact with it. Secondly, damage to utilities can occur. Insufficient separation can lead to damage to both the water pipe and the electrical service line during excavation. This can result in costly repairs, service disruptions, and potential fines. Thirdly, code violations can occur, as failing to meet the minimum distance requirements specified in local building codes can result in code violations, fines, and project delays. It may also require re-excavation and correction of the improperly installed utilities. Fourthly, corrosion can occur because close proximity between water pipes and electrical service lines can accelerate corrosion of the metallic components of both systems. Stray electrical currents can cause electrolytic corrosion, weakening the pipes and electrical conductors over time. This can lead to leaks, failures, and the need for premature replacement. Fifthly, there is potential for service disruption. Damage to either the water pipe or the electrical service line can disrupt water or electrical service to the property or surrounding areas. This can cause inconvenience, discomfort, and potential economic losses for residents and businesses. Sixthly, there is a risk of structural damage. If the excavation is near a building's foundation, inadequate separation between utilities can compromise the structural integrity of the foundation. This can lead to cracks, settlement, and other structural problems that can be expensive to repair. Seventhly, there is a risk of environmental contamination, as damage to water pipes can lead to water leaks, which can saturate the surrounding soil and potentially contaminate groundwater sources. Similarly, damage to electrical service lines can release hazardous materials, such as transformer oil, into the environment. Eighthly, there is a risk of legal liability. If someone is injured or property is damaged due to improper separation of utilities, the responsible parties, including contractors, property owners, and developers, may face legal liability and financial penalties. In addition to the general guidelines mentioned previously, there are some additional factors and considerations that can influence the minimum separation distance between water pipes and electrical service lines. Firstly, the presence of other utilities is a concern. If other utilities, such as gas lines, sewer lines, or telecommunication cables, are present in the excavation area, additional precautions may be necessary to maintain safe clearances between all utilities. Consult with local utility companies to determine the required separation distances for each type of utility. Secondly, soil composition is a factor, because the type of soil in the excavation area can affect the required separation distance. For example, highly corrosive soils may require greater separation to prevent damage to water pipes and electrical conductors. Conduct soil testing to determine the soil's corrosive properties and adjust the separation distance accordingly. Thirdly, the type of electrical service is a factor, because the voltage and amperage of the electrical service can influence the required separation distance. Higher voltage services may require greater separation to prevent electrical arcing or interference with nearby utilities. Consult with a qualified electrician to determine the appropriate separation distance for the specific electrical service being installed. Fourthly, the presence of underground structures is a factor, because if there are underground structures such as vaults, manholes, or tanks in the excavation area, it is important to maintain adequate clearance between these structures and the water pipes and electrical service lines. Consult with the structure's owner to determine the required clearances. Fifthly, accessibility for maintenance is a factor, because when determining the separation distance between utilities, consider the need for future maintenance and repairs. Ensure that there is sufficient space to access and work on each utility without disturbing the other. Sixthly, local amendments to codes are a factor, as local jurisdictions may have amendments to the National Electrical Code or a Uniform Plumbing Code that specify different separation distances for water pipes and electrical service lines. Always consult with local building officials to determine the applicable requirements for your project. Seventhly, the use of protective barriers is a factor, as in some cases, it may be possible to reduce the required separation distance by installing protective barriers between the water pipe and the electrical service line. These barriers can be made of non-conductive materials such as concrete or plastic and can help to prevent electrical arcing or interference. Eighthly, documentation is a factor, because it is important to document the location of all underground utilities, including water pipes and electrical service lines, on as-built drawings. This information can be used to prevent damage to utilities during future excavation projects. Remember that consulting with a qualified plumbing professional, electrical contractor, and local building officials is essential to ensure compliance with all applicable codes and regulations. They can assess the specific conditions of your site and provide the most accurate guidance on the required separation distance between water pipes and electrical service lines. They can also help you to identify any potential hazards or challenges that may arise during the excavation process and recommend appropriate safety measures. When planning an excavation project near underground utilities, there are several important steps to take to ensure safety and prevent damage. Firstly, you should contact local utility companies before you dig. Call 811, the National Call Before You Dig number, to request that utility companies mark the location of underground utilities in your excavation area. This service is free and can help to prevent accidental damage to underground lines. Secondly, you should review utility plans, as obtain and review utility plans from local utility companies to identify the location of water pipes, electrical service lines, and other underground utilities in your excavation area. These plans can provide valuable information about the depth, size, and material of the utilities. Thirdly, you should conduct a site inspection by performing a thorough site inspection to identify any potential hazards or challenges that may affect the excavation process. Look for signs of underground utilities, such as manholes, valve boxes, and utility markers. Fourthly, you should create an excavation plan by developing a detailed excavation plan that outlines the scope of the project, the location of utilities, the excavation methods to be used, and the safety precautions to be taken. Share the excavation plan with all workers involved in the project. Fifthly, you should use safe excavation practices by using safe excavation practices to minimize the risk of damage to underground utilities. Hand digging or vacuum excavation may be necessary when working near utilities to avoid damaging them with heavy equipment. Sixthly, you should provide proper support by providing proper support for excavation walls to prevent cave-ins and protect workers from injury. Shoring, sloping, or benching may be necessary depending on the depth and soil conditions of the excavation. Seventhly, you should monitor the excavation closely by monitoring the excavation closely for any signs of damage to underground utilities. If damage occurs, immediately stop work and notify the appropriate utility company. Eighthly, you should have emergency procedures in place by developing and implementing emergency procedures to address potential hazards that may arise during the excavation process. This should include procedures for responding to gas leaks, electrical shocks, and water line breaks. Ninthly, you should provide worker training by providing all workers involved in the excavation project with comprehensive training on excavation safety, utility location, and emergency procedures. Ensure that workers understand the risks associated with working near underground utilities and the steps they can take to minimize those risks. Tenthly, you should document all inspections and procedures by documenting all inspections, safety meetings, and emergency procedures that occur during the excavation project. This documentation can be used to demonstrate compliance with safety regulations and to identify areas for improvement in future projects. Remember that safety is paramount when working near underground utilities. By taking the necessary precautions and following established safety procedures, you can minimize the risk of damage to utilities, protect workers from injury, and prevent costly delays and disruptions. Furthermore, there may be variations based on specific circumstances. Firstly, private utilities are a factor, as the guidelines discussed primarily focus on public utilities. Private utilities, such as those serving individual properties or specific facilities, may have different requirements. It's essential to identify and locate all private utilities in the excavation area and adhere to any specific regulations or guidelines that apply to them. Secondly, conflicting information is a factor, as in some cases, there may be conflicting information from different sources regarding the required separation distances. For example, local building codes may differ from national standards or utility company guidelines. In such cases, it's best to consult with multiple sources and seek clarification from local authorities to determine the most appropriate and compliant approach. Thirdly, phased excavation is a factor, because in large excavation projects, the work may be conducted in phases. As the excavation progresses, the location of utilities may change or become more complex. It's important to reassess the situation at each phase of the project and adjust excavation plans and safety precautions accordingly. Fourthly, the presence of encasements or duct banks is a factor, as utilities may be encased in concrete or routed through duct banks to provide protection and support. These encasements or duct banks can affect the required separation distances and excavation methods. Consult with utility companies to determine the appropriate procedures for working near encased utilities or duct banks. Fifthly, permits and approvals are a factor, as excavation projects near underground utilities may require permits and approvals from local authorities. These permits may specify certain conditions or requirements that must be met during the excavation process. Obtain all necessary permits and approvals before starting work. Sixthly, the use of ground-penetrating radar is a factor, as ground-penetrating radar is a non-destructive technique that can be used to locate underground utilities. This technology can be particularly useful in areas where utility plans are inaccurate or incomplete. However, it's important to note that ground-penetrating radar has limitations and should be used in conjunction with other utility location methods. Seventhly, continuous monitoring is a factor, as during the excavation it's essential to continuously monitor the work area for any signs of utility damage. This includes visual inspections, as well as monitoring for unusual sounds, odors, or vibrations. If any signs of damage are detected, immediately stop work and notify the appropriate authorities. Eighthly, proactive communication is a factor, because maintaining open and proactive communication with all stakeholders, including utility companies, contractors, and local authorities, is essential for ensuring a safe and successful excavation project. This includes sharing excavation plans, coordinating work schedules, and promptly addressing any concerns or issues that arise. Again, for precise requirements, always consult your local building code or a qualified plumbing professional. They can assess the specific conditions and provide the most accurate guidance.